Alright, Chapter 3, Bridge Elements. Section 1, Substructure Elements. Typical bridge in case or somewhere over the figure 3-1 bridge basically consists of the two main with the part of the substructure and the superstructure. Substructure include the loose part of the transfers load from the bridge span down to the supporting ground. The single span structure from the substructure consists of two abutments, while for is multiple span structure if there are one more piers. And sometimes the steel bent with the towers are used instead of the pier with the loads are applied substructure through the bearing plate with the transmitted through the abutment wall of the piers column and to the footing of the soil is adequate. The strength of the footing of the distributed load over the significantly sufficiently large area of the footing themselves must be supported on pile foundations extended down into the firm underlaying of the stratum. 3-2 abutments. Abutments are substructure for the supporting the end of the single span with the extreme end of the multi-span substructure, usually with a retaining supporting the approach embankment. The typical abutments are shown in Figure 3-2. The abutments usually consist of a footing stern breast wall with a bridge seat with the back wall with the wing walls. The back wall prevents the approaching of the embankment for soil from spilling onto the bridge seat. While bearings of the superstructure are situated with the wing wall with the retaining with which keep the embankment soil under the abutment spilling of the waterway with the roadway with the span by the bridge. The U-shape of the wing walls due to the parapets and the railings are often placed at the top of the abutment, may be constructed with plain concrete, reinforced concrete, stone masonry, or a combination of the concrete and stone masonry, plain concrete or stone masonry abutments, usually gravitativity structures, while reinforced concrete abutments must be the cantilever and counterfort types. 3. The piers and bend. The tip of the pier with the bend shown figure 3-3 with the piers that transmit the load with the superstructure of the foundation. Material to provide with the intermediate support between the abutment and the footings of the column of the stem with the cap of the main element of the pier with the footings are slab of the transmit the load with the solid of the rock. Some of the other footing foundations and fill the pile with the casings of the drill shaft and the column stem to the transmit the vertical load with the mountain of the footing of the cap. The receiver the distribution superstructure the load with the river bridges, the railway bridges, some highway underpass the directly with the solid wall pier. Highway grade separation of the normal with until the multi-leg pier with the cap of the binding with the whole unit of the ridge frame of the bends with the basically pier without footing the tip of the row with the two more posts and pile with the guys tied together at the top of the cap of the pier with the bends may be made with timber to seal with the concrete station stones, a combination of the material of the pile with the transmit the bridge low to the foundation material of the foundation or on also over the deep water and swift streams. Typical pier pile types are steel H piles and timber concrete pile of both CIP and precast stress, concrete filled pipe and shell piles. Section 2 substructures. General the superstructure. Section 2 superstructures. 3-4 general superstructures include all those parts with the support of the substructure with the main with the part of the beam of the bridge span with the vehicle force or trim of the bridge deck and the supporting beam of the girder of the spans into the substructure of the reinforced concrete slab bridge with the simplest type of the structure since the slab carries the load of the vehicle directly to the abutment of the piers on beam with the girder bridge bridges slab of the support of the longitudinal steel with the concrete with the timber member in which the term of the carrying of the load of the abutment or pier with some of the structures consider the deck of the floor system to a more main supporting main members. Figure 3-4 some of the several different types of the superstructure and the associated elements of the components of the superstructure are summarized in the following paragraphs. Alright, 3-1 show the wing wall, the span 1, 2, and 3, the abutment 1, bent 2, 3, and 2 and 3, truss bearing, the pier 4, panel 1, which your lower chord, your worn truss, and then your span 4, 5, 6, 7, piers 5, 6, 7, bent and abutment and bulkhead span in direction around. Kind of like hold, so I'm sorry. 3-5 deck. The deck of the portion bridge with which provide the direct support with the vehicle or pedestrian travel the deck with the reinforced concrete slab with the timber of the floor with the steel plate with the grating with the top of the surface of the button and the concrete member for the unit while the normal distributing load with the beam for the string of the deck with the may also be the main supporting element of the bridge as within a reinforced concrete slab structure for the laminate of the bridge with the wearing course over the deck provided with the ridging of the plate on the top of the structural portion of the deck. They are also wearing course support integral of the structural flap and the deck is reinforced with the monolithic deck. The floor system may be consistent closely spaced through the floor beams between the girders. Refer to the deck of the girder of the bridge of the figure 3-4 sheet 2 part C. The several longitudinal string with the cover of the transverse floor beam that refer to through the girder of the figure 3-4 sheet 2 part C and floor of the top of the string with the usually wide flange beams while the floor beams may be plate girded while wide flange beams are trusses with the floor beams only are maybe rolled beams and plate girders. Several of the floor systems are shown in figure 3-5. 3-7 show the main support bearing. The main support member the main support members. Main support members transmit all the load of the floor system to support on all points of the piers and abutment to the strength and safety of the bridge support, but it depends on soon. Alright, the importance on the button, the strength of the safety of the bridge structure depends primarily on the main supporting member of the members. These members may be timber steel over the concrete beam with the steel promote plate with the girder, timber steel with the truss with the concrete ridge with the frames, arches, various material, the steel cable. The most general type of these materials members are the discussed as follows: the roll beam. The roll beam used for the short span that comes in the rolling mill as if the integral unit if the component with the two flanges of the web of the flange resist the bending of the moment and the web resists for the shear of the moment. Common type of the rolled beam shape that is shown in figure 3-6. Plate build-up curve. The typical structural member is achieve the intermediate span length with the not required with the truss with the requiring member larger with the rolled beam with the basic element of the plate with the girder or web with which for the flange or riveted the well with the top of the bottom of the edges. The most of the common forms of the cross section are shown on the figure 3-7 of the components part of the plate girder are as follows. The figure 3-7 of the flange angles are those with the riveted plate girder with the area tensile with the compressive of the fourth with the induced by bending. Alright, this shows the full height and abutment, the footing, the breast wall of the bridge seat, the back wall of the wing, and this shows the back wall of the bridge seat, the breast wall, and the footing. This shows the stub abutment, the bridge seat, the back wall, bridge wall, breast wall, wing. Show the back wall, breast seat, breast wall, footing. This shows a open abutment with the show the footing column and the cap beam, the back wall of the bridge seat, the wing. Show the back wall, bridge seat, cap beam, column, footing. Alright, your typical concrete abutments, end dam, bridge seat, footing, and then show the end dam of the bridge seat. Cover plate. These well with the riveted at the top of the bottom with flange cover. They increase the load carrying capacity of the bearing. The system over the plate with the angles of the bearings vertically. The location of the support with the attachment of the web. The primary function is to transmit shear stressing into the web plate with the bearing device is being preventing the web crippling and the buckling. And intermediate stiffeners are they even the point of the concrete load with the deep of the girder to prevent the web crippling and the buckling. Concrete beam. These beams are usually reinforced with a tensile strength with the result of the bending and shear with the combination. Therefore, they produce the lab with the dead loading. Are designed with the care with the metal reinforcement with the concrete take compression from some of the shear with only the common rectangular tape shape with its depth dimension greater than the stem width. Just show the pier cap, the column and the web wall with the footing. Show the pier cap, the column and the footing. Show the column pier with the solid wall, bent web wall. Show the web wall, column, footing, pier cap, column bent on open piers, footing, pier cap, column. And then show the steel bent, show the steel pile, the braces, and steel cap. They cantilever pier with a hammerhead, steel footing. And then you have the bent cap on pile, bent concrete piles, and solid pier wall, pier cap, footing. Trusses. The truss is one form of the structural system that become the character to provide with a high load carrying capacity that can be with the span greater than the length of the roll beam with the truss function basically the same with the manner of the roll beam with the girder with the resting of the load with the top of the bottom of the cord acting with the flange of the beam with the diagonal members acting with the web. The most trusses are steel and timber truss that exist with the treble truss members with the connected to the rivets, bolts, pins. Although the configuration of trusses varies widely with the essential component upon the common to all the truss members that all dealt with the up section, rolled section, tubing, piping, eye bars, and solid rods. As early as the commonly used the construction practice, the commonly used the channels and by lacing bars and the shade plates at the end of the interior vertical and diagonal of the old bridges may consist of the relatively slender solid rods. One member is subject to only the tension when the two opposing tension diagonals are provided in the panel of the truss. They are termed counters. The parts of the truss are summarized with the figure 3-1, 3-4, and sheets part 1, part B, and 3-8, with the discussed as follows. Alright, this shows a masonry arc bridge, the abutment, your skew back spring and line, soft fit, the introduce, clear axis span, rise, keystone, S-span roll, facing, backing, hutching, earth fill, curtain wall, pappet, Broadway level, ringstone, arch, voicers back, voicers, ridgestone, voicers pier. And this shows your typical substructure of the sway frame, your top cord, your top lateral bracing, your bottom cord, your bottom lateral bracing, your floor beam, and your stringer and shoe, your stringer bracing, your hip vertical and top cord. This shows your width of the floor beam and the deck girder and the main girder, and this shows the girder bridge with the stringer through the girder, floor beam, stringers, deck girder. This is the steel stringer bridge with a curved treaded with the deck and lateral brace connections, bearing plate stringer. Alright, chord. In a trunk of the upper and lower of the longitudinal member, the extent of the full span of the length of the call of the chord. The upper portion of the designated of the upper top of the chord with the correct corresponding lower portion of the designated of the lower bottom chord with the simple span of the top of the chord. Always compressed from the bottom of the chord will also be the intended for the should be conservative. The main structural member of the failure of either chord will render the truss unsafe. The diagonals of the diagonal web member between the success of the top of the bottom of the chords will result with the tension of the compression depending on the truss configuration. Diagonals are most mainly structural member that failure that would be extremely critical to the render of the truss of the unsafe. Vertical member to the span between the top and the bottom of the chords, which will resist the tension from the compression stresses depending on the truss configuration. Most verticals are main structural members of the failure would usually critical render the truss unsafe. So this would be your typical floor system, knee brace, and then the main girder, lateral braces, and floor beam stringer. This is your typical floor system, floor beam, bolts, shop rivets, stringer, girder, bolted splice. This show the 3-5 show the typical floor system, sheet 3, stringer, lateral gosset, plate, lateral brace, floor beam. This show the typical the rolled steel beam, show the standard I-beam, the wide flange beam, and the channel section. The bearing footing of the diaphragm of the abutment and the bridge seat of the back well. Parallel, the panel point with the intersection primary web of the chord member of the structure the note the items 5 through 11. The consideration secondary structural member although the failure should receive the immediate attention of the individual member to fail will not render their structure unsafe. The portable brace is found with overhead at the end of the strength of the truss that provides lateral stability. The shear transfer between the trusses bracing the bracing spans between the truss of the interior panel points provide the lateral stability. Shear transfer between the trusses. Tap lateral brace within line with the plane with the top of the chord provide lateral stability between the two trusses with the resistance of the wing stress. Bottom lateral bracing. These braces lie in the plane of the bottom of the chord provide the lateral stability resistance of the wing stress of the floor beam. The floor beam spans between the truss of the panel point with the carry loads from the floor stringer to the deck system to the trusses. The stringer of these span between the floor with the primary support for the deck system of the deck loading was transmitted the stringer through the stringers to the floor of the beam with the truss. The gusset blade with the plates contact with the structural member of the truss and the older truss of the pins are instead of the gussets. Alright, bracing. Individual member of the beam with the girder structurally attached together, the diaphragms cross with the frame with the truss for the tag together, and portable with the cross frame with the swing with the brace with the diaphragms cross frame with the table level with the beam with the truss or trusses and distributed load between the figure 3 and the diaphragm. Usually solid the weld member to either the rolled shape of the build with the cross frame with the truss or the panel with the frame. So the portal and the sway brace will help maintain the cross section of the bridge of the position from the deep of the clearance of the required permanence. For the portals usually are in the plane of the end post carry lateral forces from the top of the chord bracing into the support of the figure 3/8 sheet 1 lateral bracing plate at the upper part of the lower chords of the flanges, both levels of the transmit lateral forces such as wind into support figure 3/8 sheet 3 and 3/8 sheet 4 3 and 3/9. Alright, this shows the cross section. It shows the top flange weld your web plate and the bottom flange your web plate flange angles and riveted cover plates. This shows the typical longitudinal section, a bearing stiffener, a bottom flange, cover plate, an intermediate stiffener, splices, plates, flanges, and web plate, and then it's split, and then it continues. This shows figure 3/8 shows the truss components, the portal, and the end post, and then you have the truss components would be the upper chord, the gosset plate with the batten plate, switch A plate, and lacing, and then you'd have your truss components, upper chord, lateral strut, upper lateral sway brace, vertical counters. Your truss components show the top laterals, lateral strut, upper chord, and then this would be your truss components of the real panel point, pin connection, lower chord, eye bars, vertical floor beam connection. Alright, this shows the bracing sheet 1, and then bracing, lateral bracing, and then section 3 miscellaneous elements. Alright, bearings. The bands, let's just see how much we got left in here. Like, we're on page 35. I'm going to pause it. Alright, section 3, miscellaneous elements. Just testing. Alright. Bearings. Bearing transmit the substructure of the load with the substructure of the permanent superstructure that undergo the necessary move with developing harmful without developing a harmful overstress. They are virtually important function with the structure. If they are not kept in good working order, the various stuff that may be due for the structure that could shorten the usable life of the structure. Bearings are two general types of fixed and expansion. Fixed expansion resists the lateral longitudinal movement of the substructure to permit the rotation of the expansion bearing with allow with the longitudinal movement of the count with expansion contraction with the substructure. Superstructure. Depending on the structural requirement, the bearings may design with a resist vertical uplift of the bearings of the metal with the elastomeric. Typical metal bearings are shown in figure 310, 311. The numeric bearing pads, figure 312, that have become popular choice of expansion bearing. They are made of the rubber-like material with the lasso meter bowl, the rectangular pads, or strip. The note, but the bearings can be used with support and suspended span, shown figure 313. 310, pin and hanger support. Their devices used to suspend its section. Canti-levered sections, figure 314, the connection to the three affixed at one end of the shown figure 315, 316. 311, expansion joint. Since all the materials expand with the track with change with the temperature provision for the may be made with the bridge, superstructure for the permit the movement of the take plate with the damage without damaging the bridge on very support superstructure for the usually sufficient yielding of the foundation allow the small amount of the movement to occur with the difficulty without difficulty. On larger structures, however, the specification design expansion joint with it provide with the deck where only moderate amount of the movement expect the joint may only be the opening before the abutting of the part with the water. Tight seal is desired. The pre-mold of the filler topped with a pour line, poured in place with a seal to perform with the compression seal with the insert with the figure 317 sheet 1. Traffic is heavy, the unpredictable edge for the joint with the usually armed with the seal angle of the seal. Set in the concrete, largely moved that must be accommodated with the sliding plate with the finger plate with the expansion joint with maybe with the finger 317 sheet 2 with the drop fluid often provided with beneath the finger plate with expansion joint that catch the water from the roadway. 312 approach. The approach provided with a smooth transition between the roadway placement, pavement, and the bridge deck. This is important to begin with the bridge for the impact force for the acting on the bridge approach of the usually result the volume charge of the either the settlement of the backfill material from the general conservation subsoil approach of the field while the bridge is supported on pile that does not settle at all. To avoid problem of the differential settlement approaches, the slabs are often used with a span of 15-25 feet filled immediately behind the abutments. Alright, it shows your fixed bearing with a sole plate, wing plate with a masonry plate, and then B would be your simple expansion bearing. The continuous length of the stringer, loose steel span 60 feet, 50 feet elastomeric pad span 50 to 100 feet bridge seat. And then it shows your expansion bearing with a sole plate, wing plate, masonry plate with a dowel on the max eccentricity. Your stringer, continuous length of the shoe pin stand, the pedestal, the pin sole, the rollers portion of the cylinder with the roll, keep the bridge seat, and the masonry plate roller expansion bearing. Your metal bearings, and then it shows your sole plate and masonry plate, and then a metal bearing. Metal bearings is in sheet 3, 4. 3, 4. Metal bearings 404 rocker, and shows a anchor bolt, sole plate, elastometric pad, and a key, and elastometric strip. Elastometric strip. Alright, railings, sidewalks, and curb. The railings should be sufficiently withdrawn to prevent out of the control vehicle going off the bridge. However, many of the existing bridges have vehicle with the guardrail with a little bit better than pedestrian handrails, such for the guardrail if they are inadequate safety easily damaged for the vehicle with a suspected deterioration. On other hand, the unyielding guardrail poses a hard hazard to vehicles, traffic, a particular stroke for the head-on, unprotected purpose for the purpose for the similar danger. Sidewalks are provided to protect the pedestrian crossing the bridge. The curbs are on with the concrete, wooden aerial railing inside even the roadway to the guide with the move of the vehicle way for the safeguarding bridge trusses, railings, other construction existing outside of the road unit, and also pedestrian traffic upon sidewalks from the collision of the vehicle to their load. 314 deck drains. Bridge drain is very important for the citizens in traffic upon water, especially when the colder climate can cause a great deal of the damage for the bridge and safety hazards. Therefore, effective system of the drainage to carry the water away as quickly as possible, essentially with the proper maintenance of the bridge. 315 utilities is common for the commercial and industrial utility highway right away with the adjacent area that provide goods and services for the public that mean for the sum of the utility operations will be found with a number of the bridge structures. These operations may be one or more of the following: the gas, electricity, water, telephone, sewage, and liquid fuels. Utility companies performing most of their facility installation must be required for the maintenance, while the large commercial will they enter proud of the gas light with telephone company with the usually perform scheduled maintenance of the facility with the smaller publicly owned utility water companies are less likely to perform adequate maintenance since they may not be as well staffed. Utility lines and pipes are suspended from the bridge between the beams and behind the fascias. On the older bridges, the water pipe the sewer pipe must be installed along the side of the bridge with the may suspended under the bridge. This shows the hanger, and the wind block, the pin and hanger thing, 314. 317 lighting on the bridge will consider the white way lighting, signal light, the traffic control light, the navigable light, the aerial obstruction light, with the last two types of lights. There's special categories with encounter with the only the bridge over the navigable waterways and bridges having the high towers that will, of course, many bridges, but will not lighting at all. 317 dolphins and vendors. Dolphins and vendors around the bridges protect with the structure, the structure of the against the collision maneuvering vessel fenders system that absorbs the energy. Physical contact within the vessel with the air staff of the dolphin fenders are foul. Dolphins. Timber pile cluster of the type of the dolphin widely used for the cluster timber of the pile driven over the harbor, bottom of the top of the pole together, wrapped tightly with the wire rope. Figure 318. Steel tube dolphins are commonly coated with one more steel tube that's driven into the harbor, bottom of the connected to the top of the bracing with the fender system. The casing ends are sand-filled sheet pile with a cylinder of large diameter over the top of the cup of the concrete slab. Fender is attached to the outside of the sheet. Fender timber band with the shear of the timber piles with the timber wet wallers and braces attached to the top of the steel U with the figure 319. Steel piles are sometimes used in lieu of the timber. Coffer dammers. Large bridges that are wide with the footing of the coffer dammer sheet to the left and play with the brace of the concrete wall act as a pier of the protection of the girder of the grillage of the timber of the other resistant material over the outside of the sheet in the form of the collision mat. Steel pile fenders, steel pliers driven in the pairs to form in the pairs to form the frame of the concrete slab tying with the pile together to make it a good fender of the timber. The grillings are attached to the outside to absorb the collision impact. Steel concrete frames are sometimes called cantilevered from the pier of the face of the timber to rubber cushioning to reduce the collision impact. 5. Timber girder ways consider the posts of the wallers attached directly to the piers. Figure 318. Floating frameworks with a partially complete with the support of the pier with a sometimes used for the main frames are and show the detail of the road surface of the expansion dam, the slab, the field measure, the conveyor, the dam, the pin, the hanger plate with the girder web, and the pin. This shows the exploded view of the free pin hanger connection, the nut washer pin cap inside of the hanger, the cantilever arm, your suspended girder, and your end of the tapered spacer washer, outside hanger, bolt, washer, pin cap, washer, nut, spacer, bolt, washer, pin cap, washer, nut. Usually made of the steel concrete timber cushion to the outside with the strips of buttle rubber fenders. The buttle rubber fenders made to use with this fender system. 318 welded bolts and riveted welding to use with the both the joint with the two of the metal forms together the melting metal at the joints. Using it with additional metal with the welding and rod with the when cooling the welded base metal form a continuous almost homogeneous joint. The two of the basic type of the welds are shown in figure 320. Bolts A3 the A325 high strength bolt has been common in primary field fastener structural steel. Specification usually called the heavy hexagonal structural bolt, the heavy semi-finished hexagonal nut, one or two washers, bevel the washer may be required. The rivets are sometimes used instead of the bolts, especially in older structures. And then this the cantilever suspended with the washer, 2-pin center length, and then the field measured with the design dimension and the center length of the pin. Cantilever span with the field measured with the design dimension, the 2 center line pins with the center line pin. This shows your expansion joint in sheet 1 of 2, and then this shows the expansion joint sheet 2, and then show the 318 timber pile cluster dolphin fenders. 319 show the timber bent fenders, and this show the basic weld types: your single V butt joint and your fillet weld. Chapter 4: Mechanics of bridges.